All right, here we go. Lesson 3, laws of logarithms. So the last lesson we went through, we discovered these laws of logarithms. Okay, and we're going to be using these to solve a variety of things, well, to solve and simplify things. So evaluate each expression by applying the laws of logarithms. So this one is going to be the logarithm of a product because we're adding two logs. So if we're adding two different logs, we're going to multiply the 9's here. So it becomes 9 multiplied by 9. And we get log 3 of 81. And if we evaluate this, you will actually get 4. That kind of makes sense because you could evaluate each part separately. It's basically 2 plus 2, okay? Because 3 to the x equals 9, so that x must equal 2. And so each part of them is going to be 2 plus 2. The second one here on the right, log 3, 54 minus log 3, 2. This is the logarithm of a quotient. So we will divide. So 54 divided by 2 gives us log 3 of 27, and we can actually evaluate that right to 3. Okay, this one we're doing logarithm of a power. So what we can do is we can bring that 16 to the front, and we're going to get 16 log 3 of 9. And log 3, 9 will simplify to just 2. So this becomes 16 multiplied by 2, which gives us 32. All right, when we're dealing with radicals, you could do this a variety of different ways. The first one I'll show you is the quotient. So we will do root 45 over root 5. Okay, and one of the ways that you could evaluate this is to take this to 45 over 5 to the half, because each of them is a square root, so the power is half. And from there, you can bring the half to the front, and then 45 over 5 will simplify to 9, and then log 3 of 9 is simply 2, and half multiplied by 2 will simplify to 1. All right, when we have three different logs, we can still use the log rules. So the first thing we should do is to get rid of these coefficients, all right? And we can do that by bringing them back up as exponents there. So the first one is going to simplify to log a x to the half, and then we've got plus log a y cubed minus log a x squared. Okay, so we're adding and then subtracting, so we're going to apply the product and the quotient law of logarithms. And if we create just one logarithm, a, and we're going to have x to the half multiplied by y cubed over top of x squared. Now x half and x squared can simplify to x negative 3 over 2 y cubed. Okay, and we can leave it like that. You could also change that to log a of y cubed over x 3 over 2. You could also put that into radical form. And that would be the cube root of x squared. Or sorry, the square root of x cubed. Got that backwards. Now try expanding using the laws of logarithms. Okay, well, m squared is being multiplied by m, so the first thing we could do is split up m squared and add that to log b of n. And then you could bring the 2 down and we get 2 log b of m plus log b of n. All right, log 2 of the cube root of mn. So let's just get this to the exponent 1/3. Okay, now you could bring 1/3 down to the front, and we get 1/3 log 2 mn, and that will simplify to 1/3 log 2 of m plus log 2 of n. Right, in terms of log x and log y. So we actually have 3 things here. We've got log 100 plus log x plus log y. Now log 100 simplifies to 2, because if you recall, if there's nothing written there as the base, oops, that highlighter is way too big. If there's nothing written there, the default is 10. Okay, so what 10 squared becomes 100, so log of 100 can simplify to 2. And we'll just leave these as log x and log y. All right, this will become log x squared plus log y, and then bring the 2 down and you get 2 log x plus log y. This is the quotient rule, so we're going to have log x minus log y squared, and that becomes minus 2 log y. All right, if x equals log 4 of 5 and y equals log 4 of 3, express log 4 of 225 in terms of x and y. What the heck do we even do here? Well, let's prime factor 225 and just see what happens. So 225, if you prime factor it, you get 5 multiplied by 5 multiplied by 3 multiplied by 3. So in other words, we get 5 squared multiplied by 3 squared. So if we go back to the original log 4 225, this will become log 4 of 5 squared multiplied by 3 squared. And if we split that up, we'll get log 4 of 5 squared added to log 4 of 3 squared. Give ourselves some more room here. Bring the exponent 2 down, so we get 2 log 4 5, and added to 2 log 4 3. Now we're told that log 4 5 equals x. Okay, so I'm going to substitute x here, and I'm going to get 2x. And then we're also told that log 4 3 is equal to y, so this becomes plus 2y. We're good to go. Use the properties of logarithms to evaluate the expression log 3 330, given that log 3 of 10 is approximately 2.1 and log 3 of 11 is approximately 2.2. So a couple of clues here, 11 and 10 and 330. Well, 11 multiplied by 10 is 110, and then 110 multiplied by 3 gives us 330. So log 330 will become log 3, and then 11 multiplied by 10 multiplied by 3. And then we can create 3 different logarithms. So log 3 11 plus log 3 of 10 plus log 3 of 3. Now we're told that the first part here is approximately 2.2, and this is approximately 2.1, and this is 1. So 2.2 plus 2.1 plus 1 is 5.3. Use the properties of logarithms to evaluate the expression log 5 of 1 over 270 in terms of p and r, where log 5 6 is p and log 5 of 9 is r. Okay, so the clue here is we need to get the number 270 using 6 multiplied by 9 multiplied by some other number. Okay, well 6 multiplied by 9 is 54, and if we divide 270 by 54, we'll get 5. Okay, so 270 is 6 times 9 times 5. So start with your original one here. Log 5 of 1 over 270. Now this fraction is a little prohibitive. So what we're going to do is we're going to create changes to 270, but to the -1 exponent. Okay, if you recall, 1 over x is equal to x negative 1. So we're using that exponent rule in logs. So bring the -1 to the front, and you don't have to write -1. You can just call it negative. And 270 we're going to split up into 9 times 6 times 5. So 3 separate logarithms. We've got negative log 5/9 plus log 5/6 plus log 5/5. All right. Now log 5/9 is r, and log 5/6 is p, and this is going to be 1. So if we distribute the negative, we get negative r plus negative p minus 1 is a simplified expression.